We need to find the magnitude and direction angle of vector k, and then estimate any irrational numbers to one decimal place. So let's start by taking a closer look at this vector. Vector k has an x component of -34 and a y component of -7. And if you remember, in order to solve for a vector's magnitude, there's a formula we can use, and it says that the magnitude is equal to the square root of the x component squared plus the y component squared. So the magnitude of vector k would be equal to the square root of -34 squared plus -7 squared. Now we can start simplifying. -34 squared is 1,156, and -7 squared is 49. When you add those together, we get the square root of 1205, and if you rounded that to one decimal, you would get 34.7. So the magnitude of vector k is 34.7. Now let's start working on the direction angle. We know that the cosine of an angle is always equal to adjacent over hypotenuse, and it's the same way in vectors. But we know that in vectors, the adjacent side is the x component, and the hypotenuse is always the magnitude. So the cosine of theta would be equal to -34 divided by 34.7. And now to get theta by itself, we'll take the inverse cosine of both sides. And when you put this into the calculator and round to one decimal place, and make sure that your calculator is set to degree mode, you get theta equal to 168.5 degrees. But if we look at 168.5 degrees, it would be in the second quadrant. And we know that the direction angle for vector k would actually be in the third because both components are negative. So if you had a negative x component and a negative y component, it would be somewhere here in the third quadrant. So in order to place this angle, 168.5 degrees, in the correct quadrant, what we're going to do is take 360 degrees, in other words, a full circle, and subtract 168.5 degrees until we get an angle here in the third quadrant, and that will be the direction angle. So when we take 360 degrees, which is 180 plus 180, and subtract 168.5, we can do this in our head. 180 minus 168.5 is 11.5, and if you add that to 180, you get theta equal to 191.5 degrees. And we know that this is the correct direction angle because it would be located in the third quadrant where the vector would be. The final two answers to problem 4 are the magnitude of k equal to 34.7 and the direction angle theta equal to 191.5 degrees.